down to a reasonable limit.
It's not the number of questions. Oh, no, I don't want to do that. Okay, let me show you the question first. Okay, the question number 4 is the one that is going to be a little tough. I probably won't ask anything like this difficult. I'll show you why this is kind of difficult. It has to do with there's a lot of Boolean expression stuff that you have to do to get the answer right. So I'll probably simplify that for the exam. But the nature of the question will be about the same. We have line 23 to line 26, it's a conditional statement that does not have an else. Now, you might think that, if I have an else in the statement, that makes it more complicated than the one without the else. It's really quite the opposite. Because with an else, it is explicit you have the other branch to evaluate. Without the else, the other branch is quote-unquote invisible. Okay, so it's very easy to forget, for people to forget, oh, you mean there's another way to get from here to there. A lot of times people forget about the other branch when there's no else, because the else reminds people, oh, if the condition is not true, this is the other path that we have to take. So given that post 26, so at the end here, we know that x is greater than y. That's all that we know. I want you to deduce what is the precondition of line 23. In other words, if I know for sure that at this point x is greater than y, then what do I know, before line 23 for sure? Use a word processing program, or Notepad is fine. If you want to use Notepad to edit your answer and submit the file as your response. The reason why I do not want you guys to use the inline editor is, one, the inline editor, there's no way you can actually save, without, clicking one of these buttons, save without submitting. And then the second reason is, some of you want to use Chrome. When I walked around last time, I looked at how people do things, and some people use Chrome, which I can definitely understand, why you want to use Chrome. But when you use Chrome, you don't have access to the HTML editor anymore. Now, when you don't have access to the HTML editor, all those special symbols like less than, greater than, those special symbols, sometimes the computer does not take it correctly, because the less than symbol is also the beginning of an HTML tag, and if Moodle only takes that as the beginning of an HTML tag, that means most likely than not the rest of the document will be lost. So that's why I want you to also upload a file in the question like this. So this way you can use Notepad if you want to use Notepad. You can use WordPad if you want to use WordPad. You can use Word if you want to use Word. You don't have to use OpenOffice for a question like this. So this way you can save the file on your thumb drive, just in case you have to move from one workstation to the next. The file goes with you. And then when you upload the file, there's no problem. You don't leave anything for Moodle to decide. There's no formatting done in Moodle at all in this case. So that's why I changed the format of a question like this, from the first exam. Because in the first exam, I think I took it as as using the HTML editor, and a few people kind of got burnt because of that. So this time I use an upload to kind of make sure that does not happen. So that's exactly what I will do here too. I'm going to use a plain text editor. You don't have to do anything fancy. Okay, just use a plain text editor like Notepad in Windows is fine. And I'll just go ahead and copy the question, or at least enough of that into here, so that I can use only one window. I only have to look at one window to get this done. That. Now, with this question, I did not indicate, how I allocate the points, because in the actual final exam, I will tell you that you have to go back first to pre-23, and then you have to go forward again to validate your answer. Because if I go back, I can have quote-unquote a suspicion of something, but I don't know whether that really is the answer until I move forward to see if I can get back to the same post condition. So I'm just going to work on this, step by step, line by line, and show all the steps involved. If I know that post 26 is x is greater than y, can I say something about post 25? In other words, if I know the condition x is greater than y after the entire conditional statement, can I say something about post 25?
It'd be the same thing, wouldn't it?
It'll be the same thing, right? Does it make sense that it has to be the same thing? Okay. So that's not the difficult part. Well, the slightly more difficult part is if I know after line 25 x is greater than y, and all I did here is to subtract 2 from y, what do I know before line 25? Well, first of all, is there anything I can say before, for pre-25? Let me say this again. After line 25, I know for sure that x is greater than y. And what I did on line 25 is to decrease the value of y by 2. So before I decrease the value of y by 2, what can I still say something about x and y?
X is still greater than y.
We don't know whether x is greater than y, but we know that x is greater than y minus 2 before line 25. Does that make sense? Well, just give yourself an example. Okay, let's say after line 25, x has a value of 30 and y has a value of 29. 30 is greater than 29 is true. Okay, no problem. But that 29 of y is only 29 after line 25, and line 25 decreased the value of y by 2. So that means before line 25, y had a value of 31. But guess what? 31 minus 2 is 29, so I can still establish the relationship between x and y. I just have to remember to say that x is now greater than y minus 2 before line 25, and not just greater than y. Is that making any sense? Sort of? Okay. And once I know what is pre-25, I can also say something about post-24, because lines 24 and 25 are consecutive. Okay, if I know post-24 is x is greater than y minus 2, can I say something about pre-24? Right? But pre-24 has one more thing that has to be true. Okay, what else has to be true on line 24 before line 24 executes? Being the first line in the then branch. What makes it special?
X is less than y.
X has to be less than y. Okay. Very good. In other words, the condition of the conditional statement has to be true in order for line 24, in order for me to reach line 24. The first question now you have to ask yourself is that possible? Can I find a combination of x and y so that x plus 2 is greater than y minus 2, and yet at the same time x itself is less than y? Sure, I mean there are a few cases where this will be true. So as long as this is not false, you have to keep it the way it is. If this is false, that means the branch itself is a dead branch, because a dead branch means that the precondition is false. But in this case, this is not false. We can definitely find a few cases where this can happen. If I know this is the case, can I say something about pre-23? Not necessarily. X is less than y is a condition that we can impose only on line 24 because it is the first line in the then branch of a conditional statement. In other words, now this is where a picture will be helpful. If you draw a picture of this conditional statement and label the various places of that picture with the conditions, I think it would be a lot more clear why we can do certain things and we cannot do other things. A conditional statement is a branch, okay? And in this case, the branch depends on whether x is less than y or not. If it is true, we go this way. If it is false, we go the other way. If it is true, we go here, and we have two statements to execute. We have x gets x plus 2, and we have y gets y minus 2. and then we merge these two branches together, and then we get out. Okay, that's the picture of this type of conditional statement. And this is why I said without the else, some people will forget this branch here because it is not actually spelled out in the pseudocode. Our post condition says something about here. It is, x is definitely greater than y after the merge of the two branches. Using, these reasonings, we can get all the way up to here and say at this point we know that x plus 2 is greater than y minus 2, and we also know that x is less than y. But the x is less than y is only because the fact that we took this branch. It's not something that we can guarantee all the way up here. Okay? So the question is, what can we guarantee all the way up here?
Either x is greater than y or x is less than y, less than or equal to y.
Well, we can probably take the whole thing here and say that that's one thing that can make it happen. Okay, that's one thing. But what is the other thing?
X is going to be greater than y.
Greater than or equal to y.
Okay, so the part that I have written here is assuming that we are coming back here from the left-hand side. Okay, if we come back from the left-hand side, then this entire thing has to be true, including the fact that x is less than y. But we have another way to go back too. The other way to go back means that x is greater than y is preserved the entire way. Because there's no code here in between that can change the value of x or y. Is that making any sense? So that means if I go the other way, the or here, the disjunction, is just to say that x is greater than y. Okay? But hold on a second here, Tack. That's not right, because if we took this branch, the else branch here, doesn't that mean that this part is saying that x is greater than y because of this? But since we are on this branch here, doesn't that also mean that it is not the case that x is less than y, which means and x is greater than or equal to y? That is absolutely true. Okay, you definitely want to say that x is greater than y and x is greater than or equal to y. But this is redundant. Why is that redundant? Do you see one condition including the other one? Which one includes which other one? Which one is the more restrictive one?
Greater than.
The greater than is more restrictive. When you have a conjunction, an and, you only keep the more restrictive one when one overlaps the other one completely. In other words, what I want to say is, technically speaking, if you want to do it, really step by step and by the book, you have to say that x is greater than y, and that comes from here. But at the same time, you also have to say x is greater than or equal to y, which comes from the fact that this is coming from the false branch of the conditional statement. Is that part okay? So technically speaking, this is what you have to write. But when you do something like this, you can simplify that. And the simplification is saying that this is a conjunction. When you have a conjunction and you have two conditions that are overlapping, you can keep just the more restrictive one, which in this case is this part here. X is greater than y is already implying that x is greater than or equal to y. And that's why you can simplify it. And that's why in the second step here, the first part, there's no way to simplify this one. So I would have to leave this one the same way as it was. But the second part can be simplified to just x is greater than y. And that's because x is greater than y implies x is greater than or equal to y. Are we doing okay so far with this code, with this derivation? And that's what we have. Yep, go ahead.
Where does x is greater than y come from?
It comes from the fact that we are coming back from the false branch of the conditional statement. And anything, if this is coming back from the false branch, that means the condition of the conditional statement has to be false. And if x is less than y is false, it means x is greater than or equal to y. In other words, if I want to make one more step out of this to be more complete, this is what it needs to be. The negation of the condition of the conditional statement. It comes from that. Where does the x is less than y come from? X is greater than y. That's our post condition. It's all the way down here. If we know for sure that after the merging of the two paths that x is greater than y, then we go all the way back to here and say that it has to be true here as well, because that's the other branch that we can take to go back to the beginning of the conditional statement. Mm-hmm. Okay, so now we have pre-23, but we are not done yet, because we want to go forward again to make sure that we can get to the same post condition by the time we get to the end of the conditional statement. So from here, we are moving forward again. So move forward to prove that the precondition is correct. Okay. So looking at this statement here, if I move forward, what do you think is pre-24? Just using the template that we know from the notes here. Pre-24 is going to be the same as pre-23, and also the fact that x has to be less than y. Is that making any sense? That comes not from only this example. This is true for all conditional statements. If you go to the then branch, that means whatever is true before the conditional statement has to be true, because we haven't had a chance to modify anything, and because we don't have any subroutine calls in this case. When you have subroutine calls, it's a different story. But in addition to whatever was true before still has to be true, we also know the condition of the conditional statement has to be true, because otherwise we would not be taking the then branch at all. So that's why you have to have a conjunction that to add this part to do the whole thing. So now we can go ahead and expand what is our pre-23. Our pre-23 is this big mess here, and the whole thing has to be using a conjunction to end it with x is less than y. That looks kind of complicated, and some parts of this looks contradictory, because this says x is greater than y, and yet this part says x is less than y. X cannot be greater than y and less than y at the same time. So immediately I can kind of tell that we can simplify this in a certain way. Can we simplify this all the way to just false? Well, I hope not, because if you simplify this whole thing to false, that means this is a dead branch and there's nothing we can do on this branch. But it might. Okay. So the question is, how do we simplify something like this? Well, this is why I said this one is a little bit complicated, and in the actual exam, I'll use something not as complicated. It's because in this case we have to use the distributive law of Boolean algebra. Do you guys remember distributive law of addition and multiplication for arithmetic? Yes? Okay. A plus B in parentheses times C is AC times BC. As it turns out, that rule applies to Boolean expressions as well. If you look at conjunction as multiplication and disjunction as addition, it works too. So that means in this case we can do something like this. The whole thing becomes blah 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 or blah blah blah. And what we do is we take this part, and then we take this part, just like the case with arithmetic. You take A and B, and then you take this part here, and you apply it to both of them. Like that. Okay, I know with all the the number of parentheses is really quite insane in this case, but if you just look at the whole structure, you can look at this thing as one single thing at this point. So this whole thing, or x is greater than y, and then you have the other thing, and x is less than y. Are we doing okay so far? This step is basically just saying A A and B, the whole thing or C, is the same as saying A or C and A, oops, B. Oh, I got it wrong. There's an and here, there's an or here. Is that okay? This is what I did to this expression here. In the actual test, in the final exam, I will make sure that you don't need to know something like this. But since this one does require this rule, I'm just explaining that. Are there any questions about this one? The distributive law of Boolean algebra. Does anyone want to prove this? In arithmetic, do you prove the distributive law of arithmetic? It's an axiom. You don't prove it, right? It's a given. In Boolean algebra, you can actually prove it. Now, how do we prove something like this? What is the big difference between Boolean stuff versus integer stuff? How many integers do we have? How many integer values do we have? Is an infinite number of integer values, right? If I give you an integer, you can always say, oh, there's one bigger than that, or nope, there's another one that is smaller than that. So no, there's no boundary to the integers. There's no such thing as the largest integer or the smallest integer. What about Boolean values? How many are there?
Two.
There are only two. Very good. So that makes a huge difference, because in something like this, all you have to do is to enumerate all the possible combinations of A, B, and C. How many possible combinations do we have when each one can either be true or false? 8. There are 8 possible cases. I know I'm digressing a little bit here, but I just want to make sure that people understand what I'm saying here. It is useful for other classes too, if you understand stuff like this, because I can say that A can be true, A can be false, because A can take on one of the two values. But when A is true, B can be true or false. When A is false, B can also be true or false. When A and B are both true, C can be true or false. When A is true, B is false, C can be true or false. When A is false and B is true, same thing, C can be true or false. When A is false and B is false, and C can also be true or false. Are you guys seeing the combination of of the Boolean variables? If I add a D, there will be 16 possible combinations. If I add an E on top of that, there will be 32 possible combinations. Now, what does that have anything to do with proving the distributive law of Boolean algebra? Well, if you can enumerate all the possible cases, all you have to do is to now say, okay, when A, B, C are all true, this whole thing is true. When A, B, C are all true, this whole thing is true as well. You can evaluate each expression individually, and over here you can say, okay, when A, B are both true and C is false, this whole thing is false, and this is false as well. Now I can do this, just looking at it, I can figure out what it is. But you can always do it, kind of more slowly and get to the same answer. So if you work out all these rows, okay, let's just say that you work out all 8 rows, and for all 8 rows, the value of this column and the value of this column, they all match up exactly. What is that telling you? That means they're equivalent. Exactly, they are exactly the same. And this is how you can prove a lot of things in Boolean algebra that you normally cannot prove for the arithmetic equivalent case. But for Boolean algebra, it is easy because you can enumerate all possible cases. Okay, it's definitely a little bit off topic, but some of you, especially those of you who want to move into electrical engineering or computer engineering, This kind of stuff you will see again and again and again and again. This is basically how a lot of the logic gates are proved. You have to prove that this implementation of a logic gate is equivalent to this better implementation of the same logic gate, and this is how you can prove that you can actually do it this way. But for our example, we just have to kind of utilize the result. Okay, so if you look at this part here, just look at this part, or better yet, just look at this part here, because conjunction is like multiplication in the way that the associative law applies to conjunction as much as it applies to multiplication. What is associative? What is the associative law? What does it say?
A plus B is the same as B plus A.
That's commutative. A times B, the whole thing times C, is the same as A times and then B times C.
Right.
Okay, you can change the ordering of the evaluation. It preserves the result, the value of the result. And it's the same thing here. So if you look at this entire thing, it is all conjunctions. So that means I can either evaluate this part first, or I can evaluate this part first. Oh, but these two look exactly the same. What do you think is x is less than y and x is less than y? Can I simplify that? And I can simplify that to what? Just x is less than y. Just keep one of them because they are exactly the same. Well, that's good because that certainly makes my job a little bit easier. So I just take this whole thing here and just copy that without the last, and x is less than y. And I think I can reduce the number of parentheses 1 here. Okay, so that part is done. What about this part here? Is there any way to simplify that? X is greater than y and x is less than y. Well, it can be simplified to a single value of, can I find an x and a y to make this happen? No. This condition is false for all possible values of x and y, which means it is just false. Okay, it is just false. Okay, well, if it is false, we'll just write it here. Well, can I simplify this whole thing a little bit more? Just a little bit. This is something or false. Or is almost the same as a plus, and false is equivalent to a 0 in addition. So this is basically saying something plus 0. Well, what is x plus 0? X. So that's why we can simplify this whole thing and just say, okay, it's just that, but if that is the only component left, I don't even need the extra parentheses anymore. Okay? And that's why I said this one is a little bit difficult, because it needs all these Boolean algebra thing to kind of narrow it down. And in the actual exam, I'll make sure that you will not need to do something like this, of this magnitude. Because this is not a class about Boolean logic. Is there a class about Boolean logic on campus? From the math department, maybe?
I don't think so.
Nobody knows? Do you think that would be helpful in programming?
Programming,
Yeah. That stuff is extremely helpful in terms of programming. All right, so now that we know what is pre-24, after all this simplification, we get back to, just that part. But isn't this a good, reassuring feeling? Because if you look at the way we went backwards, we worked out pre-24 to be like this. And when we move forward from pre-23, we got to the same conclusion, which is good. Okay, this is very encouraging because it shows that when we move forward and backwards, it gets us the same consistent result, which means we probably have not made a mistake at this point. Are we doing okay so far? Okay. Now we want to figure out what is post-24. Okay, so what is post-24? Well, let's take a look at line 24 first. Line 24 looks like this. I'm just going to copy and paste this line just so that we can look at it more locally, like this. Okay, it's just an assignment statement. If it is an assignment statement, how do we determine what we need to do to go from the pre-condition to the post-condition? We look at the right-hand side and the left-hand side. In this case, the right-hand side refers to the left-hand side, because the right-hand side has a reference to x, and x is the left-hand side. And more than that, if I use f of x to represent x plus 2 has an inverse of f prime of x, how do I reverse x plus 2? X minus 2. Very good. So if I have all these conditions satisfied, the right-hand side refers to the left-hand side, and there is an inverse for the right-hand side, which rule am I supposed to use? Use the substitution rule. Very good. So when we use the substitution rule, we say that the post condition is the result of the substitution operation done on the precondition of the same line. We look for occurrences of the variable on the left-hand side, and then we replace it with the inverse function applied to the same variable. Haven't we seen something like this before? A long, long time ago. Okay, the next step is just to expand all these things. So the first component is pre-24. So I'll go ahead and copy and paste pre-24 here. X is what we are looking for, and we are replacing that by x minus 2. So we'll put x minus 2 here. And then the next step is really just go ahead and doing all the substitution. And we'll just copy and paste it here. Every time we see x, we replace it with x minus 2. Every time we see x, we replace it with x minus 2. So now we end up with this. Now this simplification I think everybody can do. I don't think it's too much to expect people to do this simplification. This really goes to just x is greater than y minus 2, and x minus 2 is less than 1. Is that okay? All right. So if this is done, then we have post 24. Pre-25 equals post-24 because these two statements are consecutive. One is right after the other one. Knowing that, and knowing that line 25 looks like this, can we get to post-25? We know what is pre-25, which is this condition here. We know line 25 looks like this. How do we get to post-25? Pretty much the same reasoning, right? So we applied the same reasoning. On line 25, the right-hand side refers to the left-hand side, but this time we should change the symbols a little bit because this time we're dealing with y minus 2 as the right-hand side, but it still has an inverse, which we'll call g prime of y is y plus 2. Is that making any sense? If the original operation is subtracting 2 from y, then we can undo that by adding 2 back to that thing. Is that okay? So knowing that, we can use the substitution rule, which means we're going to do almost exactly the same thing with some minor differences. So this time we're starting out with pre-25. We look for occurrences of y, and we replace those occurrences with g prime, the inverse function applied to y. And now it's just a matter of doing the substitution or expanding the equation first. Like that. And now we just do the substitution. The substitution is fairly easy to do because every time we see y, we just replace that with y plus 2. Every time we see y, we replace that with y plus 2. But if you do one simplification, which is really easy, because y plus 2 minus 2 is just y, then we end up with something like this. Are we doing okay so far? Now somebody can say that, but Tack, this is not right, because when we went backwards, okay? When we went backwards, by the time we get to post 25, we can only say that x is greater than y. But yet this time we can say x is greater than y and blah 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 blah. So we have some extra information this time when we are moving forward. Is that wrong? Is this conflicting with our derivation going backwards? It's not conflicting. It's just adding some additional information. So far we are still okay, because it is not conflicting. Now we're down to line 26. Okay, so we're trying to work out what is post 26. This is the part that is also a little bit tricky. Line 26 is the merge of two paths, so we have to take both into consideration. With one path, or the path coming from the true branch, we have this part. Okay? Because what we have been doing is we went all the way back and we figured out what this is. And then we decided to move forward using using the pre and post conditions like a substitution rule, and work through this code here. And at this time we have post 25. This part here is post 25. We got this one here. Post 25 feeds into post 26 directly. So that's why we know that post 26 must have a component that consists entirely of post 25. But that's not all, because the merge point also has to take the other branch going down here. So the question is, what does the other branch look like? It is not explicitly represented in the code because there's no else. So you have to be careful about this one. What do I put here? First of all, the one thing that I must put here is it is not the case that x is less than y, because otherwise I would not have taken the false branch. Is that okay? But there's one more thing too, because I really haven't changed anything yet. So whatever is true was true at the precondition still has to be true by the time I get here. Is that making any sense? In other words, the entire pre-23 also has to be here, because because I haven't done anything yet to change any variable from pre-23. Is that part okay? It looks really simple at this point, because next line is going to look really ugly. It's not ugly to the point that we don't know how to handle it, but it is just kind of long. Okay, so what we'll do is we'll just copy and paste this whole thing here, and then we'll go back and find out what exactly is pre-23. Let's simplify this side first a little bit, because this is an easier one. Okay, it is not the case that x is less than y. It's just saying that x is greater than or equal to y. So now we want to figure out what is pre-23. Well, we got this figured out a long time ago. It is this mess here. Okay, so we'll replace pre-23 with that mess. Okay, now this is not good so far, because at this point we are not really quite sure that this is consistent with x. It's just that x is greater than y. So I really have to do some simplification here. This side at this point, there's nothing I can do to simplify that, so we'll just leave it alone and just say that, okay, we're not going to do anything about this side. But the other side, I can actually do something about it. Haven't we seen something like this before? Or something similar to that? No? Well, okay. In Boolean algebra, the distributive law applies in the opposite way as well. Okay? So what that means is A and B or C is really the same thing as A or C and B or C. Now don't do that in arithmetic, because it doesn't work in arithmetic. Because A times B, the whole thing, plus C does not equal to A plus C multiplied by B plus C. Not in arithmetic. But in Boolean algebra, it also works out. Now how do I know this works out? I can do exactly the same thing as before. I can spell out all 8 rows. If all 8 rows match, if this part and this part here and this part here matches up, then I know that the distributive law also applies, when you have and in the inside and the or on the outside. And it actually just turns out that way for Boolean algebra. Okay, so if that is the case, we can do something to simplify this. Because what we have here is a conjunction in the inside and a disjunction on the outside. I'm just looking at this and go and trying to figure out, what can. Oh, I forgot about this part here. I forgot there's actually that part and this part, and then we have the or that part. Oh, let's go ahead and try to do this. Okay, first of all, the conjunction. Try to make sure that the parts are all correct here. Okay, if you look at the parentheses, this is one parentheses, and then this entire side is inside another set of parentheses. That's the way it's supposed to be, because they're all a part of pre-23. Okay, I think I missed one parentheses at the end. It is correct now. Okay, so we can actually apply. We can apply what we learned here first. Okay, we'll apply that rule first, because we do have the conjunction on the outside and the disjunction on the inside. At this point. Okay, so we can do that first. This part is going to get a little bit messy, definitely messy. Yes. Okay, so we have this entire conjunction first. And then we have an or. X is greater than y, or and. X is greater than y. There we go. Okay. You look at this part here as the one thing that is outside of the conjunction. And then the other side is a disjunction that has one big chunk like this, and then a smaller chunk like that. And we are applying the same rule here, A or B, which is this side here, and then we have the C being, the other side, the other thing of the conjunction, and that's how we can, separate it into something like this. And is there any way to simplify that? Well, let's take a look. It looks really ugly, but it's easy. It's actually fairly easy to do. If you look at this big conjunction, this is one huge conjunction, right? With a conjunction, you can move the order of things a little bit, and it still evaluates to the same thing. There are two terms here that are conflicting. Which two terms of this conjunction cannot be true at the same time?
X is greater than equal to y, and x is less than y.
Exactly. So if you have this component and this component in the same conjunction and they're conflicting, it means false, right? But false and anything is false, so that means this entire thing reduces to false. Okay, well that's kind of interesting. Okay, so we'll say it is false. What about the other side? What about this part here? Can I simplify this a little bit?
X is greater than
Hmm?
y. X is greater than
X is greater than y, right? It is just reduced to x is greater than y because it is a conjunction. We can throw away the more general term and only keep the less or the more specific term. So the whole thing reduces to this. Can I simplify this a little bit more? What is false or something? What is 0 plus x? X. So it's the same thing here. False or anything is just that anything. So we have x is greater than y left. So now we have this much left. And can I simplify this one more time? Now remember, we are saying that with a conjunction we keep the more general side. With a with a conjunction we keep the more restrictive side. With a disjunction we keep the more general side. We have a disjunction here, and we have one side looking like this. We have the other side looking at like this. Which side is more restrictive? The left-hand side or the right-hand side? The left-hand side is more restrictive, and we keep which side again? We keep the more general one. So the whole thing just reduced to x is greater than y. So we got back what we started off with, because the question started off with telling you that post 26 is just that x is greater than y, and we got it back. Now this is definitely a lot more complicated than I originally thought. So in your final exam, it's not going to be like this complicated. It's going to be a little bit less complicated than something like this. But in terms of the general approach, does everybody understand the general approach of this question? Okay. Because we have to use a few things that we have not talked about in the class, and that's why this is not a good question to ask in the exam. But outside of the context of the exam, it is a good thing to do. I mean, it really is a good thing to do so that we know how to go forward and we know how to go backwards, and also how to apply those other rules that we haven't talked about in the class. Oh, by the way, why do I want to know something like this if I want to get into programming? Why is that important? I mean, this looks like something that should be only important to mathematicians who want to study Boolean algebra. So if I'm just a programmer writing programs or maintaining programs, why do I want to know this?
Helps you prove the logic.
Exactly, because someone might have written a program that gives you this part. Now, if you can understand and say, oh, but this is really the same thing as this, which one is easy to understand? Okay, one side is easier to understand than the other side. So if you can do the derivation, you can actually understand the program or the existing code a little bit more effectively. Or if you want to take this to a more extreme thing, if someone gives you something like this, okay, and if you can reduce the whole thing to just that, don't you think that will help you understand the program a lot more effectively? So that's why this stuff here is not unrelated to programming. It is not a good idea to ask these questions or this particular question in a final exam, but in terms of coding, programming, and understanding algorithm, what we just went through is actually very useful stuff. It's just that it's not good in the question for this class. So that's why in the final exam, yes, I'm recording that too. I will not ask a question like this. You have to use tools that we have not talked about in this class. So we have only one question to go. And it is also a trace, just like the other 3 questions before the pre and post condition one. Yep.
Can we go back to the notepad?
Sure.
On the really long one, like right underneath post 26 that you highlighted.
This one?
I think one above that.
Okay.
Couldn't we use the rule about disjunction where you take the more general side just from the very beginning, just evaluate the left and right hand side of the and statement.
Are you talking about?
Like that, and then go past the or. Like
This is one, and then this is the other one?
yeah, and then that would just give you x is greater than or equal to y and x is greater than y, and then you take the more restrictive one and you get x is greater than 1.
But we don't know whether this side is actually more restrictive or not. Because of the or here. Okay, I know this is more restrictive than that. That's good. That's good. That's cool. But before I can say that this is, actually useless, then this can actually add something to it and make it so that it is not, So in other words, before I can kick this one out, there's no way that I can know that this side, there's no way that I can know the entire side here is actually more restrictive than the other side. Okay, I understand what you're saying. You're basically saying that can we just directly apply? This is more general. This is more restrictive. We keep the more restrictive one and get the whole thing down to here, all in one single step. But we can't because we don't know whether this part here is adding to x is greater than 1. So until we know how to, until we can get rid of this part, we cannot say that this entire side is more restrictive than this side here. And the only way to get rid of this part here is to apply this to this one using a conjunction and turn it into false, so that way that whole thing is gone. Okay. So that's it's useful to do it step by step, so you don't jump from one step to another step, because if you jump from one step to another step, sometimes it looks okay, but it really does not work out when you try to work it out step by step. Okay. That's a good question, but the answer is no. We cannot actually go from one step to the next because they don't really follow. One does not follow the other one directly. Okay, this is question number 5. Question number 5 only has 6 lines, which is telling you that something else is going on here, because otherwise, I don't usually ask questions this short. But this one is not really bad. I mean, it's really just, it looks long. Okay, let's take a look at this last line here, which is the only part that is of any significance. What do you think of this?
Weird.
Well,
didn't put like 3 different inputs.
Yeah, but all we have to do is to figure out how do we evaluate those invocations, or what is the order of evaluating those invocations so that we can get to the result. Okay, so let's take a look at this line here. This line, what is the last thing that we do on line 6? What is the very last thing that we want to do on line 6 here? That would be the print, right? We want to print whatever the other side is saying. Okay, so that's what we want to do. How do we evaluate the right-hand side? I mean, how do we evaluate this entire thing? What is the last thing that we have to do for the highlighted portion on the screen? The last operator is a subtraction. Okay, very good. In order for me to execute the subtraction, I need to know the left-hand side and also the right-hand side of the subtraction. Now, in that case, you can do it one side first or the other side, but since we all read from left to right, we will go ahead and evaluate this one first. So once we evaluate this invocation, it reduces to a single number, then we only have the other side to deal with. What about the other side of the subtraction? What about this side here? It looks like a big, huge mess, so what do I do first, to get this done? Well, in this case, you can see that one invocation is specifying the parameter of the other invocation. So that tells you the order right away, because I cannot deal with the outer invocation. In other words, let me highlight the portion. I cannot deal with this invoke until I know what is going to the x parameter of that invocation. So that means I really need to deal with this one first, so that this part becomes a single number to specify parameter x. Then I can go ahead and actually execute the overall invocation on this side. Once I have both sides of the subtraction done, I can actually go ahead and do the subtraction, which reduces to a single number, then I can print it out. So that's the overall strategy to deal with something like this. It really is, step by step, what do I need to do next? And, sometimes you have multiple things you can do at the same time. You can start either the right-hand side or the left-hand side. In those cases, you read from left to right, and you start with the left-hand side. Okay, so let's go ahead and trace it. Okay, because even though I have pretty much spelled out the solution for this one, it is still useful to trace it just to see what it looks like, in the trace when we trace it, step by step and line by line. And one thing you will be surprised by this trace is how many columns we have to use. Because just by looking at this thing, it seems like, we'll have to work our way out, a few times, retract out again, and retract. That's actually not the case, okay? Because every time we only have to deal with one invocation. So I think you'll be a little bit surprised by, how many columns we actually need in this case. There's no precondition to talk about because we don't have any global variables. And so we can start with line 6. When we go to line 6 the first time, it's kind of messy, it's really long, and the only thing we can do is to say, okay, we'll resolve the first invocation. So the first time you go to line 6, you need a return info because we are dealing with this invocation first. This is what we're going to do first. So when you specify the return info, you basically have to copy the entire line. Okay, so I'm using copy and paste here. So this is line 6, and then paste the entire line here. I have to go back and just change the part that I'm invoking right now. Since I'm reading from left to right, this one does not depend on anything else. I can take care of this one first. Are we doing okay so far? Of why I'm just changing one of the invocation to a question mark? If you have multiple question marks in the return info cell, something is not right. Okay, you can only have one and only one question mark in the return info cell. Are we okay with column C at this point? Okay. Now, whenever you invoke add, you have to specify the two parameters, x and y. What goes into x this time? 2. And what goes to the y this time? 4. Very good. So that's not difficult to deal with. Okay. Once we set up all 3 columns, we can go into the subroutine. It is on line 4. Line 4 does only one thing. It returns x plus y. X is 2, y is 4, 2x plus y is 6. So we are basically returning a value of 6. When you execute a return statement, you take the return info cell, you paste it, and then you change the question mark to the value that you're returning. In this case, it is 6. And after line 4, we go to line 5. Line 5 is the end of the subroutine, so that means we have to remind ourselves where to go back to. Okay, we go back to line 6, and we also have to remember to deallocate the columns that we allocated earlier. And now we're back to line 6. But this time, when we go back to line 6 now looks like this. In other words, the rest of the program is really not useful anymore because we are just working out of the return info cell all the time now. When you look at this line, or when you look at this line 6, what would be the next thing that I have to do? I have 2 invokes to deal with. Which one am I supposed to deal with first? We talked about that already. The innermost one. Very good. So I'll just copy and paste it and replace the innermost. Oh, I pasted it in the wrong place because I have to designate this is our return info cell first. So we'll deal with the innermost first. And we'll replace the invocation that we are dealing with a question mark. And remember to give it parameter x and parameter y. In this case, 1 goes to x and 3 goes to y. Are there any questions about row 8 of the trace, how we set up the return info this time? Okay. Once we set up the columns, we go to line 4, the first line, and the only line in the subroutine that does anything useful. It's returning x plus y. X is 1, y is 3, 1 plus 3 is 4, so we are returning 4 this time. Return 4 means we copy and paste the return info cell, change the question mark to 4, and that's it. Okay, that's the end of the return statement. We go to line 5. Line 5 has to look up the return info cell to remind us where to go to. We are supposed to go back to line 6. Then we can deallocate the 3 columns. So you have to remember to deallocate every single time you return from add, because those columns are really should be deallocated. In other words, if your trace has the columns spewing out all the way out here, it is not correct, because that's not how the program is going to execute in the computer. We're back to line 6, but this time line 6 looks like this. We still have one more thing to do before we can evaluate the subtraction, because we have one more invocation of add to deal with. So we'll go ahead and copy and paste it and replace the invocation with a single question mark. But we also have to remember to set up the columns. Oh, I copy and paste it to the wrong place. No. This is our return info cell. We have to set up for parameter x and also parameter y. So what is supposed to be in x? 4. And the other one is 6. Very good. Then we go to line 4. Line 4 is returning 4 plus 6, which is 10. When you say return 10, you copy and paste the return info cell. You change the question mark to a value of 10. But we do not evaluate it here. We don't say, oh, we know what it is supposed to be or what we are supposed to print. It is -4. We don't do any type of work here. We keep it exactly the way it is. Then we go to line 5. Line 5 says we have to remind ourselves where to go back to. We are supposed to go back to line 6, and then we can now deallocate the 3 columns. Now that we are back to line 6 now looks like this. Can we print 6 minus 10? Do we know what is 6 minus 10? It's -4. Okay, so we'll go ahead and print -4. And after line 6, there's no more code, and therefore we have post. Are there any questions about this particular question? Were you guys expecting more columns to be used when you first look at the code, or did you guys kind of know that, oh, okay, we just need 3 columns in this case?
I expected more columns.
Sorry?
Yeah, I expected more.
You expected more columns. Generally speaking, unless you have a recursive subroutine, where you have a invocation inside a subroutine, then you are guaranteed that you need more columns. But on the other hand, if this is on a single line, then you only need as many columns as the worst case here. If you're invoking a few different subroutines and one subroutine needs 3 columns, one needs 4 columns, and one needs 5 columns, that means you only have to allocate up to 5 columns, because it is not in a subroutine. You're not invoking inside a subroutine. Okay. Are there any questions about Q5? I mean, Q5 is a little bit tricky, but it's a combination of stuff that we have talked about in terms of subroutine invocation. It's just that we have never combined those two together. We have seen 2 invocations on the same line. We have seen invocations inside the invocation. This is the first time I combined both of those things into the same program. No questions about this? Make sure I save that first.
Are there going to be any complex numbers in the final?
No, there'll be no complex numbers, but the records will still be used.
Okay.
Kind of like the other question that has a record.
I'm having a little trouble with the concept of that a complex number is a real number and an imaginary number.
Well, for this class, it's not a
So
math
it's not-
class, so all you have to do is to use the right member for the calculation.
Yeah.
in terms of the math concept, the imaginary number is the I part is the square root of -1. But all it is, if you look at complex numbers, all it is just a coordinate system. It's kind of like x and y. It's a coordinate system, except when you deal with complex numbers, a lot of times they don't use the x, y, like a rectangular type of coordinate system. They use an angular system.
Okay.
Yep. Yep.
Are you gonna personalize the final to ID number again, like the last example?
Probably. So you guys have to remember to put in your ID first, and then do the test. Any other questions? Any questions about the concept that we have talked about so far? I'll just be combining the concepts that we have talked about. Probably something that is already talked about. It's just that for instance, okay, let me give you a few more examples of what potentially can be asked. So let me close this one first. And start something like this. Now, if I give you something like this, okay, record x is an integer, y is an integer, and record I'm just, this part is, something that we have done so many times already, so I'm just retyping that. So if I want to write a subroutine called transpose, is that transposing? If I flip x and y, of a coordinate, is that called transposing?
Yeah.
Is it? So we'll define subroutine transpose. And pass by reference, we have, forgot one thing. A record type also needs a name, because otherwise there's no way to refer back to which record definition I'm talking about. So by ref, C is a chord, and if I say invoke swap C.x specifies x, C.y specifies y, and define sub. Do we know how to deal with this line here? Let's go ahead and give it a try. Okay, let's finish this program and turn it into a complete program. We need a stub, local. Oh, I don't care. P point is a chord, and I say invoke transpose. Use P to specify C. And define sub. Okay, so here we have a complete program. We just want to find out what it does. It's a combination of concepts. It's a combination of record and also pass by reference. So the question is, can we combine those two concepts and understand what this program, is supposed to do, throughout, the transpose subroutine and also the swap subroutine. So let's go ahead and track this one down and find out what it does. We don't need any comments because we don't have print or conditional statements, so we'll start with line number. There are no global variables, so the pre has nothing to say. Then we start with the first line of the entire program on line 21. Line 21 is just invoking stub, which means we just need a return line number because there's no return value to return to post. And we also need to reserve the space for P. Now this is something that you have to be careful first because P is not just an integer. So when I allocate space for P, since P is a chord, and a chord or coordinate has two components. It has a member called X and another member called Y. So that's why we have to allocate two columns for local variable P, one for member X and also one for member Y. Do we have any questions at this point why local variable p is taking up 2 columns? No questions? No. So technically speaking, these are the same local variable, but we need 2 columns because we need 1 column per member of this particular local variable. Now that we have set up these columns, we can continue execution inside stub. Stub has only one thing to do. It wants to invoke transpose. So we are now executing on line 19, and we are invoking transpose. Transpose is also fairly simple. It only needs a return line number. It does not return a value. And the return line number has to go back to the line that is following line 19, which in this case is line 20. The parameter that we are passing to transpose is, the parameter is C, but since C is passed by reference, we know it is an alias of some column or some columns. So which column or columns is it now referring to? It's referring to column C and D. Very good. Okay, so that's good. And once we set up the columns, we can continue execution inside the subroutine, which is on line 15. Line 15 wants to invoke swap. This is where the things get a little bit tricky, because I am trying to use c.x to specify parameter x. I'm trying to use c.y to specify parameter y. Okay, let's start with the return line number. The return line number in this case is just line 16. Then we have to specify what is parameter x and also what is parameter y. What do you think is parameter x? What is c.x, first of all? What is c.x? C is a reference to column C to column D, and I have to look at it as a coord because that's the type of parameter C. So that means I have to look at column C and column D and make sure that I interpret this as a coord. On line 15, I'm using c.x. Where's c.x? Which column is c.x?
C.
Column C, very good. So that means when I pass that by reference, I also have to say that parameter x of swap is also known as column C. Is that part okay? So this is what I said about a combination of things, because we are combining the concept of a record with the concept of passing by reference. But you can see that the concepts do not change, even though it's a new combination. We really do not change the meaning of those concepts. What about y? I'm using c.y to specify y. C is a reference to column C to column D, which is a coord. And of this coord, member y is column D. So this is also known as column D. Is that part okay? Now the rest of the program, I cannot proceed any further because I did not initialize the coordinate. So I'm swapping question mark with question mark, and that really is not going to work out. But the most important part is, how did we know that parameter x of swap is also known as C, and how do we know that parameter y of swap is also known as column D? That's the most important part of this trace. Are we doing okay with this one? It's a combination, again, of concepts. So the final will probably have, stuff like that. It's a combination of concepts that we have used already. It's just, how do we combine these things? Any questions about this one?
You're not going to leave anything undone like this one, right? Where there is no actual values to work with.
Well, then you have to say that there's no way to trace it anymore because we are referring to values that are unknown.
Okay.
But you don't know that problem. You won't know about that problem until you get to line 9, where you actually have to refer to the value of a column. Any other questions about this one? No questions? Any other concepts that you want me to go over? Concepts that we have talked about this for this entire semester. There are a few concepts that I won't ask in the notes. That has to do with the role of a developer versus test engineers versus systems analyst. Those concepts will not be asked, but everything else to be talked about in this class will be in the scope of the final exam. record member file reference. That's the name of this sample code. I mean, really, we only have this class, before the final exam, so this is the right time to ask questions if you have any questions about the concepts that we have talked about.
We go straight to the computer lab next Friday, right?
Yes. You probably want to go there a little bit early, like give yourself about 5 or 10 minutes, time, so you can settle down, log into Moodle, and just kind of wait for the test. I would also recommend using, Open Office Portable, just so that you know that you have control over the environment. And if you want to be safe, you want to do the same thing as in the previous test. Right-click on the link, save the file to your flash drive first, and then open it from the flash drive. Don't try to do what I just did here because apparently it doesn't work sometimes. I guess it has to do with the file itself. So if you do something like this, remember last time in the lab, when you try to save the file, it would crash. So don't do that. Now that we know that there's a potential of that thing to happen, instead do a right-click, save link as, and then work on the file from inside OpenOffice Calc. Any other questions? I mean, it's going to be open book, open notes, just like the first and the second exam. No other questions? As I said, I will grade all the homework assignments tonight. If I cannot get it done tonight, I'll get it done tomorrow night. So that way you guys have not only feedback for the homework assignments, but also the point values that you have up to this point. So that will give you an idea of how much effort to divert to the final exam. I mean, really, any other questions? Yep.
Can you go over the post and pre-condition, like one more example?
More examples of pre and post conditions? Okay, sure, we can do that. Okay, let's see. With pre and post conditions, I can do it with just a text editor. Let's do it that way. Okay, so do you guys want like really tricky cases or? I don't know because the other one, this one that was in the practice final exam, I did not really think it was too complicated, until yesterday. I went over this with my Tuesday, Thursday class, and as I worked it out, I was realizing that I had to use tools that we have not talked about in the class, and that's why it's not a good question to ask in the final exam. So let's start with something maybe simpler. Okay, let's start with line 6 is x gets x times 5 minus 2. Okay, so this is not a very simple thing to reverse. It is reversible. It is just not simple to reverse. Okay. So if I ask, if f of x is the right-hand side, which is 5x minus 2, what is the inverse function of that?
5 minus 2.
X plus 2
X
divided
plus-
by 5.
Yeah.
You have to reverse the minus 2 first, then you reverse the multiplication by 5. So that means this is x minus 2, the whole thing divided by 5. Okay. Now, how do we double check and verify that that really is the case? Is there a way to verify that? Just plug it in. Very good. So we plug in f prime inside f to apply to x. If all works out, I should get x back. Okay, because that's the definition of an inverse function. An inverse function reverses what the other function does, so you get back the original item. So we'll go ahead and do this and see if it works. F of something is just 5 times that something. In this case, that's something is f prime of x, and then the whole thing you want to subtract 2 from the whole thing. And now we can expand what is f prime of x. F prime of x is x minus 5 times, and then we have x minus 2 divided by 5, and then this whole thing minus 2. Is that okay? What? All right. Sorry?
Should that be x plus 2?
No, because f prime of x is this part here, so I'm just putting this part where f prime of x was. Okay.
It should bx plus 2 and add
If you-
f inverse f.
Oh, you mean the reverse part here? Okay, you're right. Sorry about that. Okay, so is that going to work out? Well, the 5 is going to cancel out the division by 5, so we'll have x plus 2 left here. And then we have a subtract 2 at the end. So you guys were right, I forgot to reverse the addition to, I forgot to turn the subtraction into an addition. And then we get x back. Okay? Now the other way to look at this is to say, okay, if you don't want to deal with a line 6, this complicated, the other way is to look at this as 2 lines. The first line, which is line 6a, will do the first operation. The first operation is just to handle the multiplication part, and then you have another line 6b to take care of the second operation, which is subtracting 2 from that product. Because if you look at it like this, then you can separate it into 2 different assignment statements, and each one is now easy to figure out what is the inverse function, because 5x has an inverse of x divided by 5, x minus 2 has an inverse of x plus 2, so now it is easier to deal with it. Okay, so if I give you something that is really complicated, you just have to chop it down into smaller components, and then each smaller component will be easier to find the inverse function. Is that okay? Is that working out? Okay. Let's work with a compound conditional statement. So we'll start with line 19. It's really somewhat arbitrary. I just want to see whether you guys can figure out the pre and post conditions of everything. So ultimately, I want to figure out what is post 25. And let's start with some knowledge about x, y, and z. So we'll say pre-19 is, we know that x is less than z and y equals 200. Doesn't matter what it is. Okay, so this is what we know before line 19. How do we proceed from here? There are 2 things we can proceed. We can work with pre-20, or we can work with pre-24, because we can work on those at the same time. So we'll just go from top to bottom and work with pre-20 first. What is pre-20? It doesn't matter whether line 20 is a conditional statement or an assignment statement, because pre-20 is still based on pre-19 and the condition of the conditional statement. Is that okay? Because if we are about to execute the then branch of a conditional statement, that means whatever is before the conditional statement still has to be true, and the condition of the conditional statement also has to be true. This is the condition before the conditional statement. This is the condition of the conditional statement. So when you expand this, it just becomes a longer conjunction, like that. Is that okay? Now that we know what is pre-20, we can look at pre-21. Now, when you look at pre-21, which is nested within 2 conditional statements, you don't have to worry about the fact that it is inside 2 conditional statements, because as far as you are concerned, this is the then branch of this conditional statement, and we know the precondition of the inner conditional statement already. So as far as we are concerned, we know that pre-21 is pre-20, because pre-20 is the condition before the inner conditional statement. But we also know that we can only get here if the condition of the conditional statement is true, which means z has to be greater than 10. Is that okay? So that means, for anything that is nested, you just have to work on it one level at a time, and you don't have to worry about the fact that, oh, but this is a conditional statement inside a conditional statement. It doesn't matter, because once you work out what is the precondition of the then branch, that's it. The outer conditional statement is no longer a factor at this point. So now you just take pre-20, which is pre-19 and that thing, which is a long conditional statement, and it just gets longer, okay, like that. So now that we know what is pre-21, what is post-21? Okay. Well, if you look at line 21, what is line 21? What kind of statement is line 21? It's an assignment statement. Okay. So it doesn't matter that you have an assignment statement now, two levels embedded within, a conditional statement inside another conditional statement, because as long as this is just an assignment statement and you know the precondition, you can either apply the forget rule or the substitution rule. Those are your only two options. Okay? When you look at line 21, which one should we use? The left-hand side, the right-hand side does not refer to the left-hand side. So you have to use the forget rule because the operation cannot be undone. So you say the right-hand side of line 21 does not refer to the left-hand side. Use the forget rule. So you basically just say forget certain things of pre-21, things that contain references to W, because W is the one that is getting changed. But you also have to say that after this line, we know that W equals 5. Now it is important not to use the left arrow in this case. It does not make any sense to use an assignment operation inside a condition, because what you want to do is not to say what you are doing to W. What you want to say is what do we know about W. You're not doing something to W, you're saying what you know about W. Does everybody understand why we cannot use the left arrow and instead we have to use an equality symbol? Okay. But fortunately, in this case, the forget operation really has nothing to do because pre-21 has no mentioning whatsoever to W. So that means we preserve the entire pre-21, and we just have to stack on top of that and say, oh, by the way, we also know that W equals 5 at this point. And that's post-21. Well, once we know what is post-21, we can try to figure out what is post-22. Post-22 is also the merge of two branches. So that's why you can start with a disjunction, because it is merging two different paths. One path is coming from post-21, so post-21 is on one of the paths. The other path happens when the condition of the conditional statement is false. But when the condition of the conditional statement is false, it also means pre-20 still has to be true. So the other side has to say pre-20 is true, and on top of that, z is less than 10 is also false, which means z is less than or equal to 10. And in this case, it just, when you expand this whole thing, it just becomes kind of messy, because post-21 is already kind of long, like this. And on top of that, you need pre-20. Pre-20 is kind of long, not as long, but just kind of long. And don't forget the other part. Z is less than or equal to 10, like that. If anyone wants to simplify this, this is a good chance to kind of simplify a little bit, because you can see that this component is common to both sides of the disjunction. So you can reverse and apply the distributive law and extract this part out so that you can simplify the equation just a little bit. I'm leaving it like this, I'm not touching it. Now we can work on pre-24. Pre-24 is the else part of the outer conditional statement. So whatever was true before line 19 still has to be true because I have not had a chance to change anything yet. But at the same time, we also know the condition of the conditional statement has to be false, because otherwise I would not be ending up in the else branch of a conditional statement. So now we can go ahead and expand what is pre-19. Pre-19 is given to us, and we can simplify not x is less than y. It is just saying x is greater than or equal to y. That's our pre-24. Once we know what is pre-24 and line 24 is an assignment statement, and the right-hand side does not refer to the left-hand side, we know we have to apply the forget rule. So the right-hand side of line 24 does not refer to the left-hand side. Use the forget rule. So that means the post 24 is based on forget pre-24. Forget anything that mentions w, but after line 24 we know w equals 10. Fortunately, pre-24 does not refer to w at all, so there's nothing to forget in this case, and then we can just say, and w equals 10. Now we are down to line 25. Line 25, or post line 25, is the merge of post 22 and post 24. So you start with that part. Okay, so you just say this is post 22 or post 24, which means that this is going to be a huge big mess, because what is post 22? Post 22 is this big mess already. And then you have to take this and say that or post 24, and post 24 is not nearly as big of a mess, but nonetheless it is still kind of a mess, like that. So this would be a good time to actually do some simplification, because you can see that we have two disjunctions, and there are three terms here that they all have this common part. And I think I forgot. Did I forget something? Nope. Okay. They have these common parts here. These parts are common to these all three terms. So you can actually extract that one and turn it into a different type of statement. Do you guys want to do that? Just push it one more step. No. Yes.
Yeah.
Okay. So we'll take that term out. X is less than z, and y equals 200. That term is common to everything, and it is conjunction with everything. So now we can say the rest is just a conjunction of this part here. So what is left is this part here. Okay. So with this, I would do something like this, just so that I know the parentheses will match up. The first one will take care of this part. The second one will take care of this part. And the third one will take care of this part. Is that okay? I can do one more step of simplification, because x is less than y is common to both of these. So I can actually take that out and also, do the same thing. Well, let's just take that one extra step. So we copy and paste this part, and I will work on the overall structure first in this case. I really can't do anything about this one, so this one has to remain exactly the same way as it was before. So I'm keeping it exactly the same way as before. On the other hand, this part can be simplified a little bit, because they both contain the terms of x is less than y. So this term becomes, x is less than y and something or something. You can see that when I write something like this, I don't really write it from the beginning to the end, because I have to make sure I get the structure right first. Then I can populate the rest of it. So I can put this into here and put that into there. So that's kind of the final answer. It's still messy. It's still a big, huge mess. Is anyone going to become a computer engineer or electrical engineer? The kind of expressions you have to deal with in those, it's a lot worse than this. This is like, a walk in the park by comparison. They have equations in electrical engineering or computer engineering, the logic gate equations. They cannot be handled manually. They have to be processed, by a program. So it gets complicated, when you get to those, when you get to the circuits, of how to implement, certain logic gates. But this is the kind of stuff that you have to do, when you're dealing with programming, designing, the gate logics of a computer and stuff like that. It's a lot of parentheses. But I kind of made this one really bad because I started off with a lot of parentheses to begin with. Okay, are there any questions? Any other things you want me to go over? I still have my office hours from 9:30 to 10:30 every day, until the final exam. So if you have any questions, just contact me and you can ask questions. Anything else? Anything else? Did I mention to you, if you cannot get into CISP 360, which is ideal, you can consider going into CISP 370, which is the VB programming class. I'm not sure how quickly that class is getting filled up. It can be filled up just as quickly as 360. But at least if you take one programming class, you will still be retaining, what you learned from this class about programming. Most people will forget their pre and post conditions the moment they walk out of the final exam. until such time they have to debug a program, then all that stuff is going to come back and go like, oh, that's right, I can actually reverse this operation, because I know the bug is here. Now I can go back a few steps without having to run the program again. Yep.
Is a 370 CSU and UC credit, or is that just kind of?
Let's take a look.
GE?
That's a very good question, and I'm glad you asked it here, because you guys don't have access to the curriculum, stuff, but I do, and I can show you how it articulates with other colleges. This is the part that you cannot access. I think at some point they will make the curriculum accessible to students as well, but at this point they are not accessible to students. From ARC. Okay, so this is the curriculum of CISP 370. It describes what the class is about to teach and what are the prerequisites and stuff like that. The advisory is CISC 310 and CISP 300. Advisory is not the same as a prerequisite. It basically means it would be helpful to have taken this class already, but it is not required. And what you want to find out is how does it articulate with other colleges. So we can scroll down right here. Doesn't say.
CSU.
For CSU.
Yeah.
Oh, CSU transfer is approved. Now, just because the class can be transferred, sometimes means the units can be transferred, but it does not. It has no equivalency to a class over at CSU, because that depends on which program you're going into. If you want to find out whether this class is equivalent to a particular class, you have to go to assist.org. That would be the good place to go. So what you do is you start with you have ARC, and then you go to the other campus. Let's say Sac State. Then you have to. Can I get rid of that? Oh, my window was just too small, and that's why it was overlapping. So now you have to select a major. I think VB is articulated with the MIS program, but not with the computer science program. So if you look here, you can go to computer science, computer engineering, or MIS. Do they have MIS? Sorry?
What's MIS?
Management Information System. They don't have MIS listed here. So the closest you can get is probably computer science. So when you look at computer science, you look through the list. These are classes, these are SAC state classes, and these are ARC classes. And these classes are articulated, which means if you take cisp300 here, it is the same as having taken cisp15 over there. And I don't think cisp370 is on the list. It is not on the list. So that means you can take cisp370, and if you get a good grade, an A, then you get 4 units of A's that you can transfer to SAC state. But it does not, it's not equivalent to any of the other classes that you have to take in that program. And I think you can transfer, X amount of units like that, so that you don't have to retake, that many units of classes over there. But my suggestion, was just, based on the fact that if you take cisp370, then you'll still be doing some programming. So the concepts that you learn from this class, it would not, you're not going to forget that, as easily, if you cannot get into cisp360 right away. Okay. Any questions about assist.org? How many of you already knew about this, and have been using it? It's really quite useful because you know exactly how to plan your classes. But now that you cannot really get into classes as easily, a lot of times, it just kind of throws off your plan to, get into the get the whole program done. All right. Well, that's it for today. If you have any other questions, just contact me during my office hour or send me an email.
You did great today.
Because it's a different link. Yes.
I know. Come on. I even double checked you in the break.
Okay.
I just